Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 35. This training module, we're going to be taking a look at doing breakpoint rescaling. Breakpoint rescaling needs to be performed if you're going from a naturally aspirated configuration into forced induction. We need to raise our engine load in our axes for our spark timing tables, variable cam control tables, as well as our torque-based tables also need to be raised to match what the torque production of the engine is going to be for a forced induction situation. We're going to go through all of the configuration details to perform a breakpoint rescale in this tutorial. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at doing breakpoint rescaling on our Gen 1 Coyote engine applications. Now, what we're going to find here is that the breakpoint rescaling needs to be done if you're going from naturally aspirated into a forced induction type of situation. So you're going from basic bolt-ons and you add a supercharger, or you just change everything up and add a turbo kit. We need to account for the increased amount of airflow or air mass coming into the engine. The engine will make more torque, so we need to do torque rescaling on our torque tables. We also need to make sure we're accounting for that increased cylinder pressure with our spark timing. So we need to do a rescale in our spark timing tables to be able to lower the spark timing amount, retard the spark timing as we're going up and getting into higher boost levels. So going above naturally aspirated atmospheric type of condition, we're going into positive manifold pressure, flowing a lot more air into the engine. It'll generate a lot more cylinder pressure, and as a result, we need to bring the timing back to keep the combustion cylinder pressure in check so that we don't have knock or pre-ignition occur. So we need to go and make a rescale or perform a rescale in our calibration files in these situations. There's going to be some general rule of thumb to follow for doing a rescale. It's relatively straightforward. Let's jump in here and take a look at how we're first going to rescale our spark timing tables. Then we'll take a look and talk about our torque-based tables. So I have a original file here, a stock equivalent file, a 2014 Mustang GT file. You can open up any file for 11 to 14 Mustang GT. It's going to be pretty much the same thing we're going to be looking at here. Let's jump into our engine tab here, and we're going to move from our general over here into Spark first. Now in here, we have our borderline tables and our maximum brake torque tables. At this point in the training course, you know what these represent, you know what these mean, you know how they're going to be related to each other. Now let's just jump into our borderline table under optimal power. Under the optimal power table, we see here on our left axis, we have our engine load, also known as air load. Now when we're dealing with a naturally aspirated Coyote engine, we'll find that 0.9 to 1.1 in our air load, essentially these last two rows, characterize what the engine load or air load will be registered in terms of the air mass being drawn into the engine. So we're not going to get much higher than 1.1, but we'll typically be between 1.0 and 0.9. So we'll fall somewhere in line of these last two rows in the table here. And that's fine. Everything will be characterized properly for spark timing, referencing the spark timing coming from our table here. The problem is going to be if we turn up boost pressure. So we're going above atmospheric pressure. We're flowing a lot more airflow or air mass into the engine. We're going to find that the engine load will naturally increase because it's a function of airflow or air mass. Now, we determine our air load or engine load, so we're going to be taking a look at the mass airflow readings, the speed density calculations for air mass. We put those together, we put them into the throttle body model, and we output an air load. So it determines air load going through a bunch of different math type of functionality, but ultimately what we get is engine load or air load. And that allows us to track essentially what the engine is doing in terms of its operation in this engine load axis. But if we start to get into boost and start to move a lot more airflow into the engine than we would otherwise in a naturally aspirated condition, we will calculate more engine load. So we're going to be in a situation where even on this last row right here, where it's commanding 8, 12 degrees of timing, that may be too much timing if we're getting up to something like 2.0 engine load. Now, when we're talking about how the engine load is going to be tracking, the general rule of thumb, if everything is scaled right with our mass airflow and the speed density calculations and our throttle body data is accurate, we're going to find that if we're at 14, 15 pounds of boost, so it'd be a gauge, boost gauge reference pressure, 14, 15 pounds, that would equate to approximately 2.0 engine load. If we're at about 7 pounds of boost, we'll be around 1.5 engine load. So you can get a rough idea of what to expect in terms of scaling your engine load in proportion to the amount of boost pressure you're going to be running. Now, it's just a loose rule of thumb, but it usually works out to be that, again, if everything is scaled correctly. So if we're getting into boost, we need to consider how much boost we're going to run. So let's just say you have a supercharger. The supercharger has a pulley and it's pulleyed up for about 10 pounds of boost. Well, that would be the equivalent of about 1.6, 1.7 engine. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.